I am going to discuss about optical object and optical image and optical object space and image space. I should have done it before, but it's completely okay. So I think this presentation and this video going to take 25 minutes or approximately. This is basics, and you can skip this video, but if you want to know optics by depth, you have to understand what do you mean by object space and image space, or do you mean by optical object and optical image, and how optical object and optical image plays a role. It's very important to understand this concept. Let's start with the object space and image space. So for currently, just look at this picture. If this is optical system, then all set of all points or rays associated with the light incident on the optical system is really important. Light incident on the optical system is called object space. Okay, so image space is simply all points or ray associated with light leaving the optical system. If light is leaving the optical system, it's called image space. If light is entering to the optical system, it's called object space. So it's central important to understand what is object space and what is image space. So according to object space and image space, we can also tell this slide. So this notation for the object and image spaces, you must understand. See, in case of object space, you don't use dash, but in case of image space, you always use dash, like that. See, so in case of object space, for focal length you just write f. For image space focal length, which is secondary focal length, f dash. Object versions l, image versions l dash. Location of the object is x, location of the image x dash. Height of the object h, which is in object space. Height of the image is s dash in. And primary focal point is f, capital F, and secondary focal point is f dash. You always see these things in your optics books, textbooks, and all the things, videos, and but people don't really know why we use dash and why you don't use dash. So it's really important to understand the difference between object space and image. In case of image space, we always use dash, and in case of object space, we don't use dash. Okay, then we are coming to the point: what is a real object, what is virtual object, and what is real image, what is virtual image. See, if we are talking about object, we definitely going to define object in object space, and if we are talking about image, then we are going to define the image in image space. It's called image space and object space. Object is defined as object space, whatever it happens in object space. Image is defined as in image space. So for real object associated with the diverging rays, whenever there is a diverging rays in object space, it's called real object. Its location at the point of origin of the ray entering to the optical system. So it's very simple. If this is if this optical system in this object, no matter what, how it light comes, if light is diverged, it's called real object. So real object means in object space light must be diverged. Okay, so virtual object, so associated with converging rays, and where that converging rays in object space. If it is optical system, if light comes like this, it's called it's called virtual object to that optical system. It's called virtual object for that optical system. So it is formed at the point where the extrapolation of converging rays, if there was no lens in intersection. Okay, I'll define it later. See, real object can exist naturally, while the virtual object can only be formed by imaging system. So it is, I told you from the very first video that in nature virtual object is impossible. Virtual object is always possible if there is converging system in front of it. Otherwise there is no virtual object. It is always real object. If rays reaching the system do not diverge but instead of converge, we have virtual object. So for the convergence we need plus refracting surface or medium, whatever. So it's central important to understand this concept. Okay, so at the same point, real image or virtual image defined at image space and associated with the converging rays. If this is the, suppose this is optical system and this is object space, So image in a image space, for example, image space, then if light converges at the image space, it's called real image. And at the same time, if this is something like optical system and this is object space, in image space, if light diverges, it's called virtual image. Virtual image associated with the diverging rays. So real image can be formed on the surface, while virtual image can only be viewed by the images formed by our eye. So it's really important. What is the great difference between real image and virtual image? Real image can be projected on the surface. It's central, but that's why in our eyes, actually image is inverted because it's real. So real image can be projected in the screen. So our retina works as a screen, isn't it? So virtual image we cannot project in the screen. It's central important. We cannot project on the screen. So real object and virtual object. See, in this presentation you will see a lot of things, but I think I cover all the presentation, but we have to go through small ray diagrams and all these things. So that's why I'm going slowly so you understand. Again, I'm coming to real object and virtual object. See, I said is object in object space. If it is an optical system, it's image space in its object space. In object space, if light is diverging, no matter what, it's real object. Okay. So sometimes it's called optically real object, sometimes it's called physically real object. Physically real object like humans and all the things, tree and all the things. So real object is formed when diverging light is incident on the optical system. So incident point is in object space, isn't it? So it's diverging light in the object space. It's simply real object. So sometimes called we physically real object like human and trees, and sometimes we call uh, optically real object. So optically real object means there is no physical appearance of the object, but some artificial generation by holograph or maybe another virtual image formed like real object. If another system creates a virtual image, and that virtual image we another system sees it as a real image, a real optical image. I'll tell you in the later of the presentation what I really mean. Just skip it for now. So this is what I am telling. This is object space, and in object space, light is diverging, isn't it? This wavefront means it's diverging wavefront. This is diverging light. It means real object. It doesn't matter what. So in case of physically real object, center of the curvature of wavefront is located in physically real object point. In case position error in the, it means if this is an object point, so wavefront center is in this wavefront center is an object. It simply means that it's not that big thing. So real image, what do you mean by real image? See, the real image means in image space, light converges and forms the image at a point. It's called real image. Simply, it's always associated with exiting wave because exiting wave means in an image space wave. So real image formed by converging light is central important to understand converging. And sometimes we call it optically real image and physically real image. So it's not big thing. Let me try to explain with this slide. See, this is optically real image. So this is physically real image because physically real light meets here. But in this case, if you put brick on the in between the focus point and light, then it's called optically real image because it cannot cross here. So it forms on the wall. So the wall blocks the image. It's simple concept, not that important. Okay, the wall stops the light and reaching the plane of physical real image. However, exiting wave front have still the converges and have the same curvature. The angle between the convergence of light leaving the system also same, hence the placement of the brick wall has no effect on the converging wave light, because if you place brick or not, light is converging. And if light is converging in image space, it's called real image. It doesn't matter you place brick or not. So optically and physically and all these things. So position align is optically, physically is all same thing. So real image is an object for the eye. I'll tell you later on what do you mean by that real image object for an eye, and I'll tell you later on. So virtual image. Let's move on. Virtual image. Virtual image means in image space light goes divergence, isn't it? That's simple. So virtual image means optical system or the virtual image. See in this second line, exiting diverging wave. It's simple that. Okay, just understand this. In an image space, if there is exiting light is divergence, it calls virtual image. Okay, so virtual image we can see in mirrors and all these things, bathroom mirrors and all these things. So in case of bathroom mirrors, you have seen these pictures, isn't it? It's a virtual image. So virtual image can serve as an optical real. Virtual image can serve as an optically real object for eyes and other optical system. It is because light incident on the optical system is divergence. I'll tell you later on. Just wait. Virtual object is very simple. It's object space, and if there is light convergence in this position in object space, it's called virtual image, virtual object, isn't it? Just finish there. You have to have other optical system which converges the light, and means for this optical system is virtual object. It's simple. So for this, so I'll give you example which is very important example. Let's see, this is an object, okay, and this is a cornea, okay, and this is a lens, and this is retina. Okay, fine. So here object space light is diverges for cornea, real object, isn't it? And now cornea is highly plus power. Now cornea converges the light, and for cornea, what it making which type of image? It's a real image, isn't it? For cornea, this after cornea, these rays are converging. Okay, for cornea, real object make real image. But see, for lens, object space is this. In object space light is converging, so real image made by the cornea acts as a what? Virtual object for lens, isn't it? For virtual object means in object space we have convergent light, and then virtual object again converges by lens, it forms real image in the retina, isn't it? So in our eye, real object forms real image, and the real image of the cornea acts as a virtual object of lens, because for lens object space light comes converging, and it further converges to the retina, and whenever for lens image space light is converging, so converging light makes image real image. So that's how in our eye it works. So for real image of one system acts as a virtual object of another system. So it's simple. So okay, so this is what you can pause and read this thing. So that's what isn't is lens and it's cornea in our eyes too. This is how it forms for real image of system of one eye and virtual object of system in other eye. Our eyes exactly work like this. See, this is the best slide I wanted to discuss. See, for L1 lens, in L1 lens object space, it's real object, isn't it? Because light is diverging. For L2, focus is here, and after diverges, again diverges. For L2, it's also real object, isn't it? For L2 object space is diverging light and forms real image, because for L2 image space it's converging light, isn't it? Okay, let's see in second. For L1, it's a real object, isn't it? For object space, it's diverging. For L1 in image space, it's again diverges because it's negative lens. So the image is virtual. So virtual image in case of this figure, and the virtual image acts as a real object, isn't it? For L2, you can see for virtual image of L1 act as a real object of L2, because in object space of L2 there is a diverging light and it forms real image because L2 image space has a converging light. Again, let's see. In case of L1, object is real object because in object space diverging light. In image space it's further diverging light. That's why virtual image in L1, and the virtual image act as a real object in case of L2, and L2 forms real image, isn't it? Because in L2 image space here light converges. See, for L1 real object, isn't it? Real object form from L1 lens image space light converges. That's why it's real image, isn't it? But see, in case of L2 or image space light is converging. That's why object is virtual object, isn't it? Because in object space of L2 light is converging, and again virtual object forms what? Real image, because in L2 image space light is converging. So for this D picture you can understand that image formed by L1 is real image. Now real image serve as a for L2 virtual object, and virtual object again forms real image. That's this D picture is exactly how our eye work. So that's how we understand what's real object, real image, virtual object, virtual image. Okay, so I have to recap it. Let's see. If it is a lens, if in object space light diverges, it's simply real object. In object space light converges, then it's simply virtual object. So this is image space. For example, this is image space. In image space light converges and forms the image. It's real image. In image space if light diverges and forms image, it's virtual image. It doesn't matter. Sometimes virtual object forms real image, sometimes virtual object can form virtual image, sometimes real object uh, can be uh, can form virtual image. It doesn't matter. We have seen a lot of cases here. You have to understand. You can come back to back, and this is a picture from Keating. You can go there and understand, which is central important to understand this concept. Okay, so I hope you understand real object, virtual object, real image, virtual image, image space, and object space. You can start from this book, Geometric and Visual Optics. This is great book, and today's presentation a lot is covered here and from here too. And this is my favorite book, Geometrical Optics by Professor Dr. George Similis. Look at all the books, and today's presentation there are a lot of things covered from these two books. So I hope it will be clear. So I'll see you on next video. Bye bye.